Okay, continuing on with this example where we know 2 points, we've kind of just proven that if we know 2 points, we can set them equal to each other, and we know that that can also be calculated as a proportion. x1 over x2 equals y2 over y1. Notice they're opposite. The same values x and y, x on one side, y on the other, but on one you have the first x, then the over top the second x, and the other one you have the second y over the first y. Okay, so now let's use that in a example here, and example 3 in your book. They're saying we know we have an inverse variation, and when y is equal to 4, when x is equal to 7. So we now know that one of the points that satisfy this is 7, 4. Okay? They're asking us, find x when y is equal to 14. Well, now we know a second point, but we only know the y value of the second point. So we're going to have to calculate the x value. So we're going to go up and use this formula to solve this problem. So let's count this as my first point. So x1 times y1 is equal to x2 times y2. Well, x1 and x1 is 7 times y1 is 4 is equal to x2. Well, x2 is what we're looking for, and y2 is 14. So we can rewrite that as 28 is equal to 14x number 2. Divide both sides by 14, and we see that x2 is the value 2. Now that we did using the product rule. Let's use the proportion that's based off the product rule and solve the same problem. In this one, I rewrite the proportion here, y2 over y1. Well, what's x1? x1 is this point right here, that's 7, over what is x2? Well, x2 is what we're looking for, x. What is y2? y2 is the second point is over here, y is 14, so y2 is 14, and y1 is 4. Now we cross multiply. Coming this way, I get 14x. Coming this way, I get 4 times 7 is 28. Divide both sides by 14, and x is 2. And that is x2 is 2. So we got the same answer using both the product rule formula and the proportion of the product rule formula. But both of those methods gave us the same answer. Okay, let's take a look at example number 4. In example number 4, all right, example number 4, what do we have? We have another inverse variation. So we know that we have the formulas that we've talked about, product rule and all that. And it says y is equal to -6 when x is equal to 9. All right, so that tells us how the inverse variation works. Now it says find y. This time we're finding y. Last time we found x. But we need to know what is y's value when x is equal to 6. That's poorly written. Let's rewrite that. When x is equal to 6. Okay, so let's figure that out. Let's just use the product rule. x1, y1 is equal to x2, y2. There's our product rule formula. And here's our first point, 9 and -6. So there's there's the 9, and there's the -6. And over here is our second point. X is 6, Y is what? Well, we got X is 6, and Y is what we're looking for. So we got -54 is equal to 6Y. Divide both sides by 6, and we end up with Y is equal to -9. Once again, I could have used a proportion of the product rule, but I don't need to. I can use any one I want. Okay, now let's use a little bit more of a complex example. And I'm going to have to use my drawing skills here. But let's say we have a lever, and it's sitting on a fulcrum. Okay, looks like a scale, right? Well, let's say I have a weight on this side of my scale, weight number 1, and on this side I have weight number 2. And coming up the middle of my fulcrum, I have a certain amount of distance, 1 that way, or distance 2. So I have weight 1 and distance 1, and distance 2 and weight 2. And they're balanced. And these things are inversely proportional. What does that mean? Is that the distance, the further the distance goes away, okay, the smaller the weight needs to be, okay, to keep the balance. So as I move out, as the distance gets bigger, the weight can get smaller. Or as the weight gets bigger, the distance has to get smaller on one side or the other to keep the balance. Okay? So that can be written as weight 1, let's do that right here. Weight 1 times distance 1 is equal to weight 2 times distance 2. So if you'll notice that, this is our X and Y values that make up the product rule. Now, let's give us a little bit more details about this problem. What if our weight 1 is 8 kilograms? And let's say that the distance of weight 1 is 1.8 meters away from the fulcrum. And we have weight 2, and it is 12 kilograms. And we want to know how far is distance 2 away. All right, so let's do the calculations. Weight 1 is 8 times the distance, 1.8, is equal to weight 2, which is 12, times the D value, or distance 2, that we're looking for. So 1.8 times 8 is 4.4 equals 12D. Divide both sides by 12. And I get 1.2 meters as the distance that I need to put weight 2 away from the fulcrum in order to have a balanced fulcrum. Okay.